Okay. Lesson 5.7, proving other quadrilaterals. Meaning we're going to show something is a rhombus today, or something is a rectangle, or something is a kite, or something is a square or an isosceles trapezoid. The reason we list out our first one twice is that we can do a rhombus two ways. You can first of all show that it's a parallelogram plus something else, or you can do it straight away. So there's two kind of strategies here. First one, first of all, show it's a parallelogram. So that would involve opposite sides are parallel, opposite sides are equal, that kind of thing. Then we're going to have a pair of consecutive sides that are congruent. Then it's a rhombus. And this is kind of the reverse of the definition, because the definition would say if the sides are congruent, then you have a parallelogram. Sorry, you have a rhombus. All right. Number two, if either of the diagonals of a parallelogram bisect the two angles of the parallelogram, then it is a rhombus. All right? So we have parallelogram plus consecutive sides congruent, or we have parallelogram plus diagonals bisecting angles. Okay? All right. Proving a rhombus straight away. Yes, so this is without necessarily proving it is a parallelogram first. And the way we do that is we say, okay, well, if the diagonals, just look at the diagonals. If they are both perpendicular and bisectors of each other, then we know that this is a rhombus. Okay? So to go straight, we would go through the diagonals to get there. Don't look at the sides, just start there. Proving something's a rectangle. So in this case, we're going to take a parallelogram plus a right angle. Okay, so if you get one right angle, then the rest of them have to be right angles, right? That would be sufficient. Or if I take a parallelogram and then look at the diagonals, and if the diagonals are congruent, so plus congruent diagonals, then I also would have a rectangle. All right. Doing a rectangle straight, avoid the parallelogram completely. Yeah. So here we would then show that a rectangle that all four right angles are quadrilaterals are right angles. Okay. I don't know why. Oh, I see. That's the missing line there. So the straight would be show all angles right. Okay. Proving a kite straight. We go for the disjoint pair of consecutive sides are congruent. Yeah. So if the disjoint pair are congruent, then it's a kite. So this is the reverse of the definition. So there. Yeah. If one of the diagonals is a perpendicular bisector of the other, okay? So then the other possibility is start with the diagonals and show bam. Now, the first diagonal, notice, is a bisector of not only the angles, but also the sides. So there are the two options. Proving something's a square. This one's pretty simple. Show it's a rectangle. Show it is a rhombus. Okay. Proving something is an isosceles trapezoid. So first of all, grab the non-parallel sides. Show that the non-parallel sides are congruent. Okay? So if the trapezoid and the legs are congruent, so here we have to have one side parallel, one pair parallel, and the legs are congruent. Then you got an isosceles. If the lower and upper base angles pairs are congruent, then it's an isosceles trapezoid. So if the lower and upper base angles, then trapezoid. Finally, if the diagonals are congruent, then it is isosceles. So again, if you have the trapezoid, so this would be start with the trapezoid, then look at the diagonals. So there's two things in that last one. All right? And looking at this proof here, number one, here we go, let's launch in. Okay, so we start off with a parallelogram. Number two, we have a right angle that's given to us, and we have an altitude. Next, we're going to say, because it's an altitude, that's perpendicular. So definition of altitude. Number five, if MK is perpendicular, then OH is also perpendicular, then I would have that OH is parallel. Get those as diagonals to MK. And if two lines perpendicular to same. Line 6. Okay. Therefore, we could also conclude from line 1 that OM is parallel to HK. Properties of parallelograms. Line 7, by definition, OHKM is a parallelogram. And again, that would be by properties of parallelograms. Okay, we got two series of parallel lines, 5 and 6, they both support that. Line 8. Now I'm going to show this angle here is a right angle. So I'm going to give that a name. I'm going to call it angle 1. Angle 1 is a right angle. Why is that? Because angle OHG is right and supplementary. Number 9. I now have a rectangle. OHKM is a rectangle. Why is it a rectangle? Because I have a parallelogram plus I have the right angle. All right. Good luck doing those problems.